Let us talk about quantities in chemical reactions by using the analogy of making pancakes. Now, in chemical reactions, we've seen the law of conservation of mass that says mass is neither created nor destroyed, it is conserved. So whatever we have on the left side of the equation of reactants, we should end up with a same mass on the right side. For our products. And we've seen how we balance equations by balancing atoms on the left side of the equation and the right side of the equation. And this helps us equate reactants to products by a given ratio that is unique for every chemical reaction. Just like when we're making pancakes, we have the number of pancakes you make depends on the amount of ingredients you use, right? So 1 cup of flour and 2 eggs and half teaspoon of baking powder will make you 5 pancakes. And this relationship can be expressed mathematically to say, okay, well, we know that 1 cup of flour, 2 eggs, half teaspoon of baking powder will give us 5 pancakes. Now that we've seen the analogy for pancakes and the recipe, which gives us a ratio to make a certain number of pancakes, we look at making molecules. And in this case, we'll work with mole-to-mole conversions. If we have a balanced equation, this is our recipe for our chemical reaction, right? So the equation here that tells us that 3 molecules of hydrogen gas react with exactly 1 molecule of nitrogen gas to make 2 molecules of ammonia. And so we equate these values just like we equated the ingredients for the pancake recipe. But since we count molecules by the moles, because molecules are so small, we can just extend the relationship and say 3 moles of hydrogen gas react with 1 mole of nitrogen gas to make 2 moles of ammonia. Because remember, 1 mole of hydrogen gas has the same exact molecules as 1 mole of nitrogen gas. They don't have the same mass, but they have the same number of molecules. That's why we can go from molecules to moles. So if we have 3 moles of nitrogen gas and more than enough hydrogen gas, how much NH3 can we make? Okay, let's use dimensional analysis and start with what we're given. There's 3 moles of nitrogen gas, and now we want to use the conversion factor that we got from our balanced chemical equation. We know that for every 1 mole of nitrogen gas, because there's no coefficient here, remember we're looking at coefficients, not subscripts. For every 1 mole of nitrogen gas, we have 2 moles of ammonia. So we're going to, since moles of nitrogen gas is on the top, we're going to put moles of nitrogen gas on the bottom. For every 1 mole of N2, we have 2 moles of ammonia. Okay? Now you see the moles of N2 cancel out and we're left with moles of ammonia. And this gives us 6 moles of ammonia. Okay? Now let's do another example. How many moles of sodium chloride result from the complete reaction of 3.4 moles of chlorine gas? Assume there's more than enough sodium. Okay. So again, we want to write what we're given. We have 3.4 moles of Cl2, which is chlorine gas. Okay, now we want to look at the coefficients, not the subscripts, the coefficients on our values. And here we have Cl2 has no coefficient, so that means there's 1 mole of Cl2 for every 2 moles of sodium chloride. So 1 mole of Cl2 gives us 2 moles of sodium chloride. You see the moles of Cl2 cancel out and we're left with moles of sodium chloride. And this gives us a value of 6.8 moles of NaCl. Okay, water is formed from hydrogen reacting explosively with oxygen gas according to the balanced equation. How many moles of water result from the complete reaction of 25.6 moles of oxygen gas? Assume there's more than enough. This is supposed to be H2 actually. Go ahead and give this a try and then replay the video to see if you got the correct answer. First thing that we want to write is what we're given, 25.6 moles of O2. Now we want to go from how many moles of O2 to how many moles of H2O, which is our product here. Okay, well, now let's use the coefficients that we have up there to give us our conversion factor of ratios. Well, we know for every 1 mole of O2, there's 2 moles of H2O. Again, we look at coefficients, not subscripts. So 1 mole of O2 gives us 2 moles of H2O. Our moles of O2 cancel out, and we get 51.2 moles of H2O.